I'm CK. Tonight we have a good one, I think, I hope. I bought a couple of videos ago, I did Neutral Labs Elymyra synth. So I went and I enjoyed that quite a bit, and I like the synth itself quite a bit. So I got Neutral Labs Nermal. This is an effects unit, Eurorack style, and we'll see how it goes together and how it sounds. I'm looking forward to this. And here's the box, unopened, and if you knew me, you'd know how hard that is not to open these immediately, but I wait to do it on camera. Neutral Labs Nermal, that's N-E-R-M-A-L, version 1.1 do-it-yourself kit. This DIY kit was packed by Neutral Labs in Leipzig, Germany, and contact information if you need it. I got this as I did the other synth from Neutral. I got this from thonk.co.uk, a nice site for do-it-yourself music and a lot of Eurorack stuff. I recommend them, and because they use FedEx shipping, it shows up at your door, and I'm in California, it shows up at your door as fast as you could expect from any other service. So I like them. Their selection is just awesome. So let's open up the box and see what is inside. Okay, got a little static bag with a resistor because you want to protect your resistors from electrostatic discharge. Just kidding. It's got one IC and a power transistor and something else that we'll look at in a little bit. Another bag of stuff. These are a bunch of capacitors, power header, a c.k.haun plus nut. That's Thonk, I-C-O-N-N, some kind of connector that Thonk must make. A bunch of other little stuff. Another bag with more other little stuff, including some dips and knobs. Then there is another bag of resistors, diodes, and capacitors, and a couple of switches. And again, bunch of small bags that you're going to open in order of assembly. The only thing I would like the crate or the kit to do would be to say number them or letter them, A, B, C, or 1, 2, 3, just so you're not guessing which bag is first. Here's the circuit board. Nice crisp silk screening, and once again the circuit board quality is excellent, and I'll point this out again as I did with their other kit. There's not just plating on both sides, the plating goes through the holes, so you're going to get a very good solder connection. You're never going to worry about having a open or a cold solder joint. These are really good boards. I would, if I were the author of this kit, I might even put their board manufacturer on my website, because if somebody else wants some good boards, I would definitely go with this and pay extra if you need to. This quality is really superior. Ribbon connector or cable, and here's the front panel. Front panel is going to have frequency, nibble, soft and hard, low and high, bite, ouch, roar, scratch, volume, and I assume this is input and output jacks, and probably, I'm not going to guess, might be patch connections because it is Eurorack style. It also might be knobs, and there's a little mouth with teeth. And there's the Neutral Labs logo. And now I have another Neutral Labs sticker that I'll put somewhere. Now, one thing obviously it doesn't have is a paper manual, but this QR code on the top will get us to the manual. So let me grab my iPad, unplug it from power for a minute. Have to password unlock it so you can't see it. And let's go to Safari. Oh, no, I'm sorry, I always get this wrong. Go to the camera app and get the QR code in view. Open neutrallabs.com in Safari. And here we are. Here's the downloads version 1 build guide. So it's got a user's guide, a build guide, and a schematic. And let's see what the words say. Congratulations on your decision to build this module. And again, do not empty any of the component bags. The components are grouped into bags, so all of them can be identified without having to look up. Rather, leave everything inside the bags and take out what you need. So, again, I'm a little bit of two minds about this, since I'm the kind of person who likes to go through all the components in a kit and put my hands on them before I start doing anything. But I understand why he does this, and I'm fine with that. So let me get my circuit board stand out, solder stand out. How do I want to do this? I think I'll go this way. And again, if anybody has better circuit board holders than this or the Panavice one, please let me know, because I'm still in search of what I want. So I'm going to do it his way, so I'm looking for the first set of resistors. So this bag has R1 through R3, R blah blah blah, all the 10Ks. I'm going to dump this bag out into my parts bin. So we'll get all the 10Ks first. Okay, so that's all the 10Ks. Now, one thing you might have noticed is I was pulling the resistors leads with my needle nose pliers, because while this board is, again, excellent, the resistor hole spacing is a little tight. I mean, I'm going as near to the body as I can with my bending pliers, and that's still not quite close enough. And I have to put them in and bend them to, tug on them with the needle nose pliers to snug them up onto the board. I would probably want a little more tolerance on resistor sizes, particularly because resistors can vary from batch to batch, manufacturer to manufacturer. Fraction of a millimeter here and there can make a difference. So, gosh, see, I even have some resistors raised up because I didn't pull them all the way down. Minor issue, but just something to be aware of. You'll want to tug your resistors really close. Okay, now we're going to do some 2K resistors, 2 of them. That's red, red, red. Of course, again, again, I'm not quite sure, and I'll be blunt here. I'm not quite sure what his intention is. You don't have to read ring codes or use a multimeter to determine the resistor values. Each bag contains unique sets of resistors, so you will not find resistors in the same bag. I think what he means is if it says, like for the next 2 resistors, there are only 2 in this bag, and there's only 1 set of 2 resistors. The other were the 1, 2, 3, 4, 5, 6, 7, 8, and there's a 3 and a 4 and a 1. So by elimination, this 2 resistor set must be that resistor, the 2.2K. I understand, but I still think I would prefer if people learn resistor color codes and have a little bit of understanding of the components they're working with. And it's not because I'm being a grumpy old man, though I can certainly play that part easily. It's really more that if something's wrong, if you put something together and I've got to pause. Sorry about that. When my water heater goes on, it makes the exhaust fan makes quite a racket. But as I was saying, I think it's important that people understand color codes and values of components if they're going to do something more than simply just plug things in. If you need to troubleshoot, if something doesn't work when you've built up a kit, having a little knowledge of what's going on is going to stand you in good stead. But that's my philosophy. It's not the right philosophy, just my philosophy. So let me put more resistors in. Okay, that's all the resistors from that bag, but he wants to put all the resistors on first, which means I have to open the other bags and have different parts trays. And again, I know I'm going on and on about this, but I'm doing it for a good reason in my mind. I think his kits are excellent. The Elymyra is excellent, and this is looking really, really good. And I'm just adding my perspective to make it even better. Because now I've got 3 bags that I'm working out of at a time in 3 separate little parts trays. If you're going to do this and you're going to make a decision, have a decision where I'm going to do it in a certain order so that assembler can't get confused and doesn't have to know too much about electronics to do this, I would probably go section by section. I would have, like Heathkit used to do and still does, even though they only make like 3 kits now. Say, bag A, put these on first. Bag B, put these next. Bag C, put these next. And he could do the same thing with the resistor groupings that he's done this way, but then you'd only have 1 bag open at a time. Again, I'm nitpicking, but I'm brainstorming ideas to make a good kit, a great kit, even better. So let me get the next bag and put a bunch more resistors in. Okay, so that's all the resistors, except for R21. Huh, where's R21? Oh yeah, remember we saw a resistor through the side of the electrostatic bag, so there are 3 resistors in here. Let's see, he violated his own rule here. There are 2 resistors here, but they're on separate. They're not on the same strip, but you're not going to get confused anyway. Oh, and one final reason why I think kit builders need to be able to read resistances is because when you drop your parts bin on the floor, or your cat jumps up and starts playing with stuff and you got to shoo him away and things get scattered, much better to be able to understand resistance bands, or at least put something on a meter. And that's the last I'll say about that. Maybe, maybe not. So that's all the resistors. Next we'll do the diodes, but I'm not going to do that right now because it's getting near 10:30 and that's time for the cats to get their treats, and they will be very upset with me if I don't get in there at the right time. So see you tomorrow evening. Okay, another evening. Now it's time for diodes. There are diodes, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 diodes on the front, and there's one somewhere back here. Here it is. There's one on the back that's an LED. So we'll do this side first. So except for the LED, that's all the diodes in that bag. Let's see what we got in here. No diodes in that bag. And here we've got a bunch of diodes, about 85s. Oops. A whole bunch of diodes. D1 through 8 first. I sometimes wonder how many miles of component wire I've thrown out over the decades. I don't wonder that very often, but sometimes I wonder it. Okay, all the diodes are in, and now the IC sockets. And we've got 1, 2, 3, 4, 5, 6 of them. So they will be going 1, 2, 3, 4, 5, 6. You get some locking tweezers out to stabilize the ICs while I solder them. And I'm going to need another parts bin. I don't know if I have one. But we'll make do. And that'll be U2. Where's the notch? Notch is there. Put the locking tweezers in to hold it in place like so. Flip it over and solder away without worrying about it falling out. So what I'll usually do is just do 2 pins at opposite ends and then take the tweezers off. So they're not in the way, and so I'm not inadvertently touching them with the soldering iron and having heat bleed away from the solder. Okay, that's all the sockets. Let's see what we have next. Probably capacitors. Oh, power header next. Now this one I usually hold in, this type of connector I usually hold in with my pinky finger and solder. The only thing you have to be careful about with that is you don't have your pinky finger on the pin that you're actually applying solder to, because it hurts. Just getting it to try and be as aligned as we possibly can, and now we can use the blue tape again to keep ourselves from is that flat? Yeah, that looks perfect. Okay, now we're gonna do a bunch of caps. Okay, now we're putting the high C's in their sockets. Now this, I mean this, I'm glad he's got a photo here because he doesn't say what chip goes in which socket specifically, so. Okay, so that is the back side of the board effectively, because the panel will actually, the front panel will be on this side. So that's all done, and that'll be it for this evening. Okay, now it's time to do the other side. And we're going to start by putting the white LED in. And again, there's not a lot of space in here. In fact, I'm going to not use my regular iron for this. Regular iron tip is a little too big, so I'm going to use my TS100, and I power it from a DeWalt battery with a little adapter I found online. It was a little kit. If I can remember where I got it from, I'll put a link in the description. Yes, I am pressing A. Okay, it's heating up. This, by the way, is very handy if you want to go solder in your car or in your living room or wherever you don't have a lot of space. And it's already at 300 degrees centigrade, so it heats up very, very quickly. And again, the main thing we're concerned about here is not brushing the soldering iron up against the capacitors, because that would be bad. Gosh darn it. I'm not getting this second lead very well. And there it goes. Okay. I may just keep using this. I have no idea how much this 4 amp hour battery will last with this soldering iron. Probably forever and ever, but we'll see. Okay. LEDs in place. Okay, so what he recommends is you put the various bits and pieces on the board and then put the front panel on it and lay it down on the ground to make sure everything is aligned properly. I'm not sure I want to do that, since I generally use the kind of elevated rig I'm using, but I may. Let me give his plan a try. So I'm going to pull it out. Circuit board comes out. Let me make sure the camera is focused correctly for this new configuration. Okay, now we want to take the nuts off the screws. Actually, that's the pot. The pots don't have backing nuts. I know what he wants. Oh gosh, that pin is really bent out of shape. Gosh. Now the switches. And we'll want to take the top nut off. Okay, everybody's standing up reasonably straight. Yep. Now it's time to drop the top on it. And let me set all the switches in one direction so it's easier to maneuver the panel down on top of them. Of course, while I was being super careful with the switches, the jacks, one of the jacks came loose, two of the jacks came loose, but I can get them back in without taking it all apart. Yep. Okay, now all the jacks are in appropriately, and there we go. Now we put the, as he recommends, you put the nuts on the pots, because the pots have little pins, locking pins on the side, so they won't come out when I flip this over to solder. I mean, they won't come out immediately. They won't take a lot of pressure, but they will hold things in place and not long enough to solder. Now I'm going to look at this. I want to make sure I've got enough threads on the jacks when we need to get to there, and I think we do. I think everything looks pretty good, so we'll flip it over and we'll do some soldering. Gosh, that's doesn't go very flat. See, if I get the jacks all the way flush with the circuit board, I don't have enough threads to really put. Actually, let me see if I do. Yeah, that'll be okay. But I'm gonna have to hold this tight on the jacks. The switches are looking okay, and the pots are looking okay. It's just the jacks need a little help to get flat against the circuit board. It's not anybody's fault, it's just the design. So what I'm gonna do is get the handy dandy locking tweezers again. Use the locking tweezers to pull the jacks up against the circuit board. Yeah, this TS100 has a whole lot more thermal mass than you might think for something so small, but it really solders very quickly. Oh, and these TS100s, there are a whole bunch of people who make them. I can't tell you particular manufacturer. Just look up TS100, and they're less. I think they're like $60. I don't really recall, but they're not expensive, and they're very handy. They're not quite as comfortable in my hand as my Weller, but for work where I've got to get in on a circuit board like this, between components, I do like it. I'm going to go ahead and solder the pots next, and then draw the front panel down a little bit onto the pots, because that would probably make the switches sit a little nicer too. Yeah, it's always interesting to me that the electronics assembly side of these kits, of any kit, is often straightforward when where the mechanical final assembly and fitment can be the place where you have the most challenges. Okay, so all the pots are soldered down, and they're really secure, big globs of solder on the mounting pins. So I'm going to take these panel nuts down somewhat snugly. See if we've got much free play. Well, we got a little bit of free play. Got a little bit of free play on this side. Let me measure this. This is looking cattywampus. So I'm getting 30/64 there and 32, so it's a couple of 64ths off. But will it come down? See, that's not going to come down. I'm not going to be, it's going to be a balancing act. I'm going to have to be balancing the depth of the threads I'm using on the pots and the screws and back and forth, because they don't all lie in the same plane. There, that will be okay. But I want to clamp that, and for this side I'm going to use locking tweezers that have vinyl jaws. So I don't scratch the front panel. And of course I think the camera went to sleep, but I don't think you missed much. I'm just putting the nuts, final nuts on the component, on the switches and knobs and jacks. Okay, now we'll put the knobs on. I'm going to be a little grumpy on the Elymyra synth. The knobs were machined metal, which I thought was really nice. I thought it gave it a real good feel. These are your standard plastic knobs, so not as fun. Again, I really like the circuit board design. I like the layout. I like the quality of the products. Except, of course, I'm nitpicking and saying the last ones had machined metal knobs. These are plastic, but that's minor. So now it's ready to go. Unfortunately, I don't have a Eurorack out here in my workshop, so I'm going to have to figure out what I'm going to do to set this up and power it up. Just for one thing, I forget what the pinouts on the power connector are, so I don't know where to connect my power. But we're done with the assembly. Now the next thing is just to test it, but it was a great assembly job. Very good kit. Alright, now it's time to put the Nermal unit through its paces. I'm not going to say I'm testing it or demoing it because I'm really not giving it what it actually needs to do any of that. It's just sitting here on my workbench out in the lab. It's not in my studio. I don't have anything out here to feed control voltage into it, and I'm just going to be giving it some random audio inputs, not something from a good rich harmonic oscillator filter set or anything like that. So this is just to give you an idea of how things sound with this unit. And you're going to be hearing it through that amplifier on the floor. That's a custom amp I built a number of months ago. You can look at that video online if you want. And I've also set up the oscilloscope so we can look at the waveform to see if anything interesting is going on with that. So let me pause a little bit while I zoom in on the oscilloscope screen. And here we go. We're going to start by using this tone generator. As you can see, it's a very tiny one. It runs on a 9-volt battery. I find it very handy. I have a full-featured audio signal generator that I use for more complex things, but if I'm simply injecting a sine wave or a square wave into a circuit, this is really handy. It's easy to set up, and it doesn't have a lot of complexity, so it's fun to use. We're going to start at 500 Hertz with a sine wave, which again, according to the author and creator of this kit, is not the best. The neural works best if there are a variety of frequencies interacting and some harmonics. But I wanted to get a baseline of what this does with a simple sine wave. And there it is up on the scope. Now let's go ahead and I'm going to make this a little louder. Frequency knob doesn't do anything in particular because nothing is being modified. So I turned on bite, and that's interesting. Now one thing I'm noticing here, there's a big jump in amplitude right there. I'm not sure I really like that. I mean, if I were using it in a studio, I'd have to go back in and adjust my gain every time I went past this point. I don't really like that. Let's turn nibble on, see if that does anything. We'll do some hard. I'm going to turn the volume down a little bit and go all the way out. So that's what it does with the sine wave. Now let's go move over to a square wave. Turn on bite again. Seems to like square wave a little more. I'm turning it off now. Seems like square wave a little bit more. That's interesting. So I'm going to swap out the frequency generator, tone generator, and bring in an old friend, an iPod. I still have an iPod or two. Sorry, that started before I wanted it to. So instead of using somebody else's music, this is a song of mine. In fact, I'll lead off the video with this, and it's available on SoundCloud if you care. And the link will be in the description. So let's go ahead and play some music through it. So that's pretty much untouched. Let's start moving in frequency. Nothing going on there. So it's adding a lot of grittiness. Okay, we'll stop there. So it works, obviously, and that's good. And it does exactly what the creator of the kit talks about. It's a destructive distortion effects unit that has some random effects, and again, probably works better with some direct input from an oscillator filter bank, and with some CV coming in for bite, scratch, and other things. But I'll work on that later when I finally incorporate this in my studio. But the conclusion is, it's a very good kit. It's good quality. It does what it says it does, and you might find it interesting for your studio. Thanks for watching.